It was a night unlike any other. The sky shimmered with 50,000 stars, scattered like diamonds across the black velvet of the heavens. Two pale moons hung low over the horizon, thin crescents glowing faintly red. The sun, an immense burning disk that had dominated the sky for weeks, had finally slipped behind jagged hills to the north. The heat of summer gave way to a cool breeze. All across the world, people gathered by the shores of oceans and on rooftops of ancient cities to stare at the stars. And then, it happened. One of the stars began to swell. It brightened and brightened until its glow drowned out the moons themselves. What had once been a faint pinprick became brighter than every planet in their sky combined. Soon, it outshone the heavens entirely. This was no ordinary star. It was a guest star, what they called the sudden violent death of a massive sun, a supernova. They cheered, they celebrated, they danced in the streets. But one astronomer did not celebrate. Watching from their observatory, they noticed the readings. A sudden plunge in ozone levels, a surge of radiation, the kind that would strip their planet's atmosphere bare in less than a week. This world, one of the first planets in the universe, was about to die in fire. The early universe was a violent place. Stars lived fast and died young. Explosions painted the cosmos with light, filling it with the heavy elements needed to build planets. But with every burst, those same explosions threatened to erase entire worlds in an instant. And yet, somehow out of this chaos, planets emerged. But here is the question. Did planets exist before galaxies themselves were born? Did rocky worlds arise in the universe's youth, before stars had even settled into the grand spirals and giants we call galaxies? This is the story of the first planets, not Earth, not Mars, not Jupiter, but the very first solid worlds to exist in the universe, and the mystery of whether planets came before the galaxies they now call home. To understand when planets began, we need to rewind time all the way back. 13.8 billion years ago, there was no Earth, no sun, no galaxies, not even atoms, only a universe, hot and dense, filled with pure energy. Then came the Big Bang. In its first seconds, the universe was so hot that particles themselves flickered in and out of existence. Quarks, leptons, gluons, the building blocks of all matter, danced in a storm of unimaginable energy. As the universe expanded, it cooled. Quarks began to lock together, forming protons and neutrons. Within minutes, those protons and neutrons fused in the first act of nuclear alchemy. The result? Hydrogen, helium, a little lithium. That was it. No carbon, no oxygen, no iron, no silicon, none of the materials you need to build planets. If you could have visited this newborn cosmos, you would not find a single rock, not a single world, not a single grain of sand. Only seas of hydrogen and helium gas stretching endlessly in every direction. But gas does not remain evenly spread forever. Gravity, that invisible sculptor of the cosmos, began its work. Tiny fluctuations in density, leftover ripples from the Big Bang, gave gravity a foothold. Wherever gas was slightly denser, gravity pulled harder. Those regions pulled in more matter, growing denser, pulling in more still, until massive clouds collapsed in on themselves. And then, ignition. The first stars burst into existence, flooding the darkness with light. These were not gentle stars like our sun. These were giants, colossal, short-lived, furious furnaces, dozens or even hundreds of times the sun's mass. They burned hot, lived fast, and died young, some in just a few million years, a blink of cosmic time. But in their brief lives, they performed the first great miracle. Inside their blazing cores, hydrogen fused into helium, helium into carbon, carbon into oxygen, oxygen into silicon, neon, magnesium, iron. The elements of planets, the elements of life. And when these giants died, and they always died violently, they exploded as supernovae, flinging their newly forged elements across the universe. The early universe was crowded. Stars were packed close together, sometimes only a few light years apart. Galaxies, not yet graceful spirals, were turbulent clumps still finding their form. Everywhere, explosions, supernovae tore across the cosmos, enriching gas clouds with heavy elements, the seeds of future planets. But these explosions also made survival difficult. Imagine a young planet forming near one of these giants. A single nearby supernova would scorch it lifeless, stripping its atmosphere, sterilizing its oceans, leaving behind only a burnt husk. Life, if it emerged, had to be stubborn. The universe was trying to kill it at every turn, but physics does not ask permission. Once there were heavy elements, once there was dust, planets became inevitable. The question is not whether they formed, it's how early. Let's be clear, a planet is not magic. It's the natural outcome of a recipe. Hydrogen and helium for atmospheres and gas giants, carbon, oxygen, silicon, iron for rocky worlds, ice and water for the possibility of oceans. With just hydrogen and helium, you get stars. To get planets, you need the other stuff. That stuff, what astronomers call metals, only comes from stars, which means no stars, no metals, no planets. So planets could not have formed until after the first stars had lived and died. But how long did that take? 1 billion years? 100 million? Could planets have appeared before galaxies themselves fully assembled? The first stars, the mysterious population 3 stars, were the true architects. None survive today. They burned too brightly and lived too briefly, but their ashes seeded the cosmos with the first planetary material. Every rock, every mountain, every ocean on Earth owes its existence to the corpses of long-dead stars. But here's the mystery. Galaxies, as we know them, majestic spirals, vast ellipticals, took time to form. In the beginning, matter was still clumping together. Galaxies were small, chaotic, and merging constantly. So could planets have formed in those in-between times, when the universe had stars, but not yet galaxies? The answer may be yes. In principle, as soon as a single star enriched its surroundings, and another generation of stars formed from that material, protoplanetary disks, swirling clouds of gas and dust, could appear. Inside those disks, dust grains would stick, clump, and grow into planetesimals. Worlds could exist even in the wild, lawless universe before galaxies found order. So when did the first real planets emerge? We can't travel back 13 billion years to check, but we can look for ancient survivors. One clue comes from TOI-561, an ancient star over 10 billion years old, twice the age of the Sun. Against all odds, astronomers found planets orbiting it, rocky planets in a time when heavy elements were scarce. Another clue, Methuselah, a planet discovered in a globular cluster, nearly 13 billion years old, a world older than the Milky Way itself. If these planets exist, then planet formation began incredibly early, perhaps within the first billion years of the universe, perhaps even before galaxies were fully assembled. So picture it. The first stars blaze to life. They die in fire, scattering their ashes. Those ashes become the seeds of new stars, and around those stars, the first planets, barren, harsh, lifeless, worlds bathed in radiation, frozen or scorched, blasted by supernovae, but still planets, and perhaps, in some ancient corner of the cosmos, on a tiny moon orbiting a giant world, shielded by ice or ocean, life may have taken its first trembling steps, billions of years before Earth was born, and all of this before galaxies had even finished taking shape. A planet is not just a wandering rock. By definition, it must orbit a star, clear its neighborhood of debris, and hold itself together under its own gravity. But in the earliest universe, definitions hardly mattered. What mattered was, could clumps of matter form, and could they last? The basic process is simple. Start with a disk of dust and gas swirling around a young star. Dust particles collide, stick, and grow, from grains to pebbles, from pebbles to boulders, from boulders to worlds. Gravity takes over, snowballing small clumps into massive ones. The largest grow into gas giants, sweeping up hydrogen and helium before it drifts away. The smaller ones remain rocky, Earths, Marses, Venuses. That is planet formation today. But the early universe wasn't like today. There was less heavy material to build with. Gas giants needed vast envelopes of hydrogen. Rocky planets needed iron and silicon. And yet, somehow, they formed anyway. Before galaxies, there were stars. And where there are stars, there are disks. The very first planets may not have been Earth-like at all. They may have been dwarf worlds, more like Pluto or Arakoth, small clumps of ice and rock huddled together in cold, distant orbits. Think of Arakoth, visited by NASA's New Horizons spacecraft in 2019. Two misshapen lumps of frozen dust fused billions of years ago. Silent, ancient, a time capsule of the solar system's birth. Now imagine billions of Arakoths forming not 4.5 billion years ago, but 12 or 13 billion years ago. These primitive bodies, icy and fragile, could have been the first planets in any meaningful sense. Small, yes. Lifeless, almost certainly. But still, the very first solid ground in a universe that had known only fire and gas. But the earliest confirmed planet is far bigger than a lump of ice. In 2003, astronomers discovered a world orbiting a pulsar in a globular cluster. Its official name, PSRB 1620-26b. Its nickname, Methuselah. Methuselah is ancient, about 12.7 billion years old. That means it formed when the universe itself was barely a billion years old. Long before the sun, long before the Earth, it orbits not a normal star, but the corpse of one, a pulsar, alongside a white dwarf. Somehow through stellar deaths and cosmic chaos, Methuselah survived. At 2.6 times Jupiter's mass, Methuselah is a giant. But if it has moons, and giants often do, those moons could have been rocky, icy worlds where chemistry stirred. Imagine it. Life evolving in alien oceans, billions of years before Earth even existed. Methuselah is not alone. The first exoplanets ever discovered were also pulsar planets. In 1992, two astronomers, Alexander Volshan and Dale Frail, found planets orbiting a pulsar named PSRB 1257+12. A pulsar is a neutron star, the dense core left after a supernova, tiny, only a few kilometers across, but so heavy that a teaspoon of its material weighs more than Mount Everest. Around this dead star are planets, their names, Draugr, Poltergeist, Phogator, named for ghosts and monsters, fitting, for they orbit a corpse. How did they form? Perhaps from the debris of the supernova itself. Or perhaps they survived the explosion, battered but intact. Either way, they are proof that planet formation is not delicate. It can happen even in the wreckage of stellar death, which means planets did not wait for galaxies to settle. They formed wherever physics allowed, even around dead suns. Closer to home, astronomers have found another clue. TOI-561, a star 280 light-years away. It looks ordinary, slightly smaller than the sun, glowing orange, but it is ancient, over 10 billion years old, and orbiting it, a rocky super-Earth, twice Earth's mass. This is astonishing. At that age, heavy elements were rare. Astronomers thought rocky planets couldn't form so early, and yet, TOI-561 has won. It races around its star every 10 hours, so close it must be scorched and lifeless. But its existence proves something vital. Planets didn't wait. As soon as heavy elements existed, planets appeared. Even before galaxies matured, planets may have already been circling their ancient suns. For decades, astronomers assumed that planets were rare, that Earth was special, that we were alone. But the past 30 years have shattered that view. Everywhere we look, there are planets, gas giants, hot Jupiters, mini Neptunes, super Earths, lava worlds, ocean worlds, ice giants, rogue planets drifting through the dark. The universe doesn't struggle to make planets, it makes them by default. If you have gas, dust, and time, you get planets, which means the first planets may have formed shockingly early, not billions of years after galaxies, but millions of years after the first stars, tiny Arakoths, giant Methuselahs, scorched TOI-561s, planets of every kind, scattered across the young universe like seeds before the forest had grown. But here's the haunting question. If planets formed before galaxies, could life as we know it needs stability, a star that doesn't explode after a few million years, a planet not constantly bathed in lethal radiation. The early universe was violent, supernovae were constant, galaxies crashed into one another, gamma-ray bursts swept through the cosmos. And yet, Earth teaches us something. Life began here almost as soon as Earth cooled. Within a few 100 million years, microbes were thriving. If life is that stubborn, then maybe it tried to emerge on early planets too. Maybe it succeeded in pockets, under ice, in oceans, shielded from radiation. And maybe for a brief, glorious time, the first creatures in the universe looked up at skies filled with guest stars and galaxies still being born. So did planets come before galaxies? Perhaps not in every case. Galaxies and planets grew together, hand in hand, born of the same chaos. But the evidence is clear. Planets appeared far earlier than we once believed. They formed around dead stars, around ancient suns, in the debris of explosions. They may have existed even before galaxies found their graceful spirals. The universe was young, violent, and raw, and yet, even then, planets appeared. The first homes, the first grounds, the first worlds, and in their silence they carried the promise that one day, life would follow. Galaxies feel eternal. They look like grand cities of light, swirling spirals and vast ellipticals, homes to billions of stars. But galaxies are not ancient compared to the universe itself. They are emergent, constructed piece by piece, collision by collision, forged in chaos. The first galaxies were not spirals. They were irregular blobs, chaotic clouds of stars clumped together, drawn by gravity but not anymore. Some physically equivalent, others merged into larger forms. Our Milky Way is the product of countless collisions. Entire dwarf galaxies were swallowed by it. In fact, some are being consumed right now. Look at the Sagittarius dwarf galaxy, stretched into streams by the Milky Way's pull, a reminder that galaxies grow by eating. So when we ask if planets came before galaxies, we need to ask, what counts as a galaxy? A structured spiral like ours, or the earliest messy clumps of stars? Because those clumps appeared very early, less than 1 billion years after the Big Bang. And if planets had already begun forming around their stars, then planets may indeed predate true galaxies. Galaxies are not just star clusters, they are recycling machines. Every star that dies returns material to the interstellar medium. Every supernova pumps heavy elements into surrounding gas clouds. Every black hole shapes the gas that flows through. Galaxies nurture stars, and those stars enrich galaxies. This cycle makes each new generation of stars richer in metals, and therefore richer in planets. The first galaxies had almost no planets, but as stars lived and died, the number of planets exploded. By the time the Milky Way reached adolescence, a few billion years old, planets would have been everywhere. Rocky Earths, gas giants, ocean worlds, ice spheres, and yet, we've found evidence that some planets existed even earlier, before galaxies were fully assembled. The cycle had already started, even in the chaos. Scattered around the Milky Way are relics of an older time, globular clusters. Globular clusters are dense balls of stars, some containing millions, packed into a space only a few hundred light years wide. They are ancient, older than the Milky Way itself, survivors from when galaxies were first assembling, and inside these clusters, planets exist. Methuselah, the ancient planet orbiting a pulsar, was found in the globular cluster M4. That makes it not only older than the Sun, but older than the Milky Way as a galaxy. Globular clusters are time capsules. They show us that planets could and did form around stars in the very early universe. Even before galaxies took their modern form, clusters of stars, proto-galaxies, were already giving rise to planets. In a sense, globular clusters are fossils, and the planets inside them are fossils of fossils, relics of the universe's childhood. Planets require metals. At least that's what astronomers believed. Stars rich in metals are more likely to host planets. That's what our data shows today. But TOI-561 and similar stars challenge that rule. They are metal-poor, ancient, and yet they host rocky planets. This flips our expectations. If rocky planets can form with very little metal, then they could have formed extremely early, far earlier than we assumed. Imagine a star cluster only a few 100 million years after the Big Bang. Its stars glow orange and faint, their disks pour in heavy elements. Yet, inside those disks, dust grains still clump, still collide, still grow. The result? Small rocky planets, fragile, rare, but real. If this is true, then planets may not only have existed before galaxies fully took shape. They may have been common. Galaxies grew by collision, and in those collisions, planets paid the price. Stars rarely hit each other directly, but their orbits shifted violently. Planetary systems were torn apart. Worlds were thrown into deep space as rogue planets, drifting between galaxies. Others were captured, forced into new orbits around foreign stars. Some were flung into intergalactic voids, condemned to eternal darkness. But chaos is not only destruction, it is creation. Collisions stirred gas, igniting new bursts of star formation. Those new stars birthed new planets, so even as planets were lost, others were born. The early universe was filled with orphans, rogue worlds cast adrift, and with newborns, fresh planets forming in every galactic merger. It was brutal, yes, but it was fertile. Today, astronomers suspect there may be more rogue planets than stars in the Milky Way, worlds without suns wandering through the dark. Where did they come from? Many were likely ejected during galactic collisions. These planets are invisible unless they pass in front of a distant star and briefly bend its light, a technique called gravitational microlensing. In the early universe, oxygen was rare. Water required both oxygen and hydrogen, but once oxygen appeared in supernova debris, water followed. Ocean worlds could have formed billions of years before Earth. Life may have had its first chance in endless alien seas, under skies lit by young stars and glowing galaxies still assembling. Perhaps the first life in the cosmos swam, not walked. Some worlds are not oceans, they are fire. Take 55 Cancri A, twice Earth's size, orbiting so close to its star that its surface is a sea of molten lava. Its day side glows with heat, its night side may be coated in hardened rock. In the young universe, lava planets may have been common. Protoplanets slammed into each other constantly, their surfaces molten for millions of years. Picture the sky from one of these worlds, a nearby star blazing huge and bright. rivers of fire flowing across endless plains, meteors striking, sending fountains of molten rock into the sky. No life could survive there, but such worlds were abundant, the fiery stepping stones in the construction of more stable planets. Not all planets were hot, some were frozen, far from their stars in the dark regions of systems. Icy worlds formed, covered in frozen methane, ammonia, and water. Some of these planets may have been ejected into interstellar space, rogue ice worlds, drifting in eternal night. But ice is not death. Beneath thick shells, heat from radioactive decay or tidal forces can melt water into oceans. On Earth, life exists deep beneath ice, around hydrothermal vents, without sunlight. Could it not also exist on these ancient ice worlds? Perhaps the first life was not scorched or drowned, but frozen, hidden in oceans beneath ice, shielded from the chaos of a violent young cosmos. We've spoken of rogue planets before, worlds torn from their stars, wandering through the dark. They may be countless. Some estimates say there could be trillions in the Milky Way alone, and they could have formed early. Galaxies collided, stars shifted, systems were ripped apart. Rogue planets were the natural result. Most are dead, frozen, but if they kept thick hydrogen atmospheres, their cores could trap heat. They could hold onto liquid water oceans beneath their shells. Imagine life on a rogue planet. No sun, only darkness. Perhaps bioluminescent creatures evolved to light their way beneath miles of ice. If so, then the first civilizations of the universe may have lived on worlds without stars, drifting far from brightness. We have seen planets that rain ice, planets that rain fire, planets darker than coal, planets brighter than stars, planets with rings and lots of rings larger than Saturn's. And we have only scratched the surface. The diversity is endless. And why is this? In the early universe, planets were not simple, uniform, or rare. They were diverse, chaotic, abundant. Some were fiery, some were frozen, some were giants, some were small, some were bound to stars, some were cast adrift. The first planets may not have looked like Earth, but they were planets all the same, and they prove that the universe wasted no time in filling itself with worlds. So what did the first planets look like? They were not just rocky Earths. They were hot Jupiters glowing near their stars. They were ocean worlds with endless seas. They were lava worlds, ice worlds, rogue worlds, super Earths, mini Neptunes. The first planets were a cosmic zoo, and their diversity shows us something vital. The universe does not make planets reluctantly. It makes them eagerly, in every form, in every place, as soon as it can. Which means planets may not only have formed before galaxies matured, they may have been everywhere, filling the young cosmos with possibilities. Possibilities for chemistry, possibilities for oceans, possibilities for life, even in the very first billion years. How do we know planets existed billions of years ago? We cannot travel back in time. We cannot watch the first stars form and see their planets. But we can use light, the oldest messenger of all. Every planet leaves a fingerprint. When it passes in front of its star, the star dims, the transit method. When it tugs on its star, the star wobbles, the radial velocity method. When it bends light from distant stars, we see a flash, microlensing. And sometimes with telescopes like Hubble and James Webb, we can glimpse planets directly, faint dots beside their brilliant stars. By combining these methods, astronomers have detected thousands of exoplanets, and some of them are ancient, orbiting stars more than 10 billion years old. Each discovery is a clue, a piece of the puzzle, proof that planets were there, even in the universe's youth. But the telescopes we have today are only the beginning. The Habitable Worlds Observatory, planned for the 2040s, will dwarf even the James Webb. It will photograph Earth-like planets directly, analyzing their atmospheres for signs of life. The Nancy Grace Roman telescope, launching later this decade, will survey entire star fields, finding thousands of planets, including rogue worlds drifting between stars. Future instruments may detect biosignatures, oxygen, methane, water vapor, in the atmospheres of alien planets, and perhaps, if we are lucky, we will one day detect the faint light of the first planets themselves, not Earth-like, not familiar, but ancient survivors orbiting the oldest stars in the galaxy. Telescopes will not just answer when planets formed, they may answer where life began. Computers allow us to recreate the past. Astronomers run simulations of the early universe, starting from the Big Bang, letting gravity and physics shape stars and galaxies. These simulations show that the first stars were massive and short-lived. When they exploded, they enriched nearby gas with heavy elements. The simulations also show that planets could form as soon as there were metals to build them, perhaps within the first 500 million years. They also suggest that rogue planets may have been abundant, thrown out during galactic mergers. Billions of dark worlds, older than galaxies, still drifting today. If simulations are right, then the first planets may have been icy dwarfs, giant gas worlds, and rocky super-Earths, not Earth-like, but real, not friendly, but possible. Here comes the deepest question. Can planets exist before galaxies? Or a galaxy is just a collection of stars held together by gravity? But stars existed before galaxies were structured. Clusters of stars, proto-galaxies, filled the young universe. And where there are stars, there are disks. And where there are disks, there are planets. So in one sense, yes, planets predated galaxies as we know them. They existed around stars in proto-galactic clusters, before spirals and ellipticals emerged. But in another sense, no, because galaxies are not single objects. They are processes, structures. Planets and galaxies grew together, hand in hand. Maybe it is not a question of before or after. Maybe planets and galaxies are siblings, born from the same chaos, growing side by side. And if planets formed so early, could life have followed? Life needs elements: carbon, oxygen, nitrogen, phosphorus. These appeared in the first supernovae. Life needs stability. Not easy in a violent cosmos, but pockets of calm may have existed. Maybe the first life arose on a moon of a giant planet, shielded by ice. Maybe it arose in the oceans of a super-Earth, its atmosphere thick and protective. Or maybe it arose on a rogue planet, lit only by geothermal heat, hidden beneath a shell of ice. If so, then life in the universe may be older than galaxies themselves. Ancient, alien, forgotten. For us, the story is humbling. We live on a planet 4.5 billion years old, orbiting a star 4.6 billion years old, inside a galaxy 13.6 billion years old. We think of Earth as ancient, but compared to Methuselah, compared to planets orbiting stars 10 billion years old, Earth is young. If life is common, then there could be civilizations billions of years older than us, civilizations that saw galaxies form, civilizations that arose when Earth was nothing but dust. Perhaps they still exist, perhaps they vanished long ago. But if planets formed before galaxies, then the possibility of ancient life is real, and we are newcomers in a universe already filled with history. So, did the first planets come before the galaxies? In a way, yes. Planets appeared around the first stars, before galaxies had finished their assembly. They were rocky, gaseous, icy, rogue. They were battered by radiation, flung across the cosmos, destroyed and remade. But they existed. The first worlds were not Earth's. They were stranger, harsher, lonelier, but they were real. And in their existence they carried the seeds of everything to come. Mountains, oceans, forests, civilizations, United States. The universe wastes no time in making planets. As soon as it could, it did. And maybe somewhere in the dark, On a world older than any galaxy, form of life once looked up and saw the first stars, and wondered, as we do now, what lay beyond.